What sort of graph are we looking at? Alright, so tell me, what type of travel graph are we looking at? Anybody? What type of travel graph are we looking at? Lovely. It's a distance time graph. What is the distance being measured in, and what is the time being measured in? Lovely. Distance is in kilometers, as you can see here, and then time is in hours. Alright, so this could possibly be a vehicle in motion. It could even be an athlete, for all you know, because especially with the distance being covered within a specific space of time, that's a real snail pace if you cover like what, 12 kilometers in like 2 hours. So this could be for an athlete, maybe training to run a particular distance. Alright, so this is what your distance time graph can look like. So let's actually do some of the things that we were doing earlier with the illustrations. Alright, so let's start off. Can anybody tell me what is the speed of the athlete for the first part of the journey? Alright, so let's just say we call this first piece here stage 1. Oh gosh, I can't see it. Alright, so yeah, let's just say this portion here from 0 to 2 hours. Can anybody tell me what is the speed of the athlete during that part of the journey? Alright, so let's see what we got. So Nadia is just in the chat, and Nadia is just saying that beautiful, the speed, she got the speed to be 6 kilometers per hour. Alright, 6 kilometers per hour. So how many people agree with that? The answer for the speed during the first 2 hours of the journey. How many people agree that the speed is 6 kilometers per hour? Raise your hand if you do. We do have a few hands popping up. Alright, nice. So we have about 6 persons agreeing with her. Make that 8. Alright, so we're going to talk about how we calculated that speed in a bit. And if possible, could we get a volunteer to tell us how did we calculate the speed of the athlete in the first 2 hours of the journey? Anybody? Lovely, lovely. So as she's saying, speed is distance over time. Alright, and in this case we're looking at the distance being covered within the first 2 hours of our journey. So how do we know that the athlete would have covered 12 kilometers in the first 2 hours? We look at the point before the graph starts to change its shape. Alright, so the top point here, this corresponds to that 12 kilometer distance. So that's why we're going to say that the distance covered is 12 kilometers. Alright, and the athlete took how long to cover this 12 kilometer distance? A total of 2 hours, because we were asking about the first 2 hours of the journey. Alright, so time taken is 2 hours. Now if I want to calculate the speed, at this point in time we just do distance over time. 12 divided by 2 is just 6 kilometers per hour. Right? Now you could also do it from the approach of it being the gradient, and you consider 2 points on the line. So you'd consider the starting point 0, 0, and you can also take the coordinates for this point, and at this point it's 2 hours and 12 kilometers. Alright, and you can calculate the gradient of that particular region of the graph just like you would calculate the gradient of a line. Alright, so m is y2 minus y1 over x2 minus x1, and you will be able to get the same answer. Alright, so if we use this as the x2, y2, we would have 12 minus 0 over 2 minus 0, and again it works out to be the same exact thing, right? 12 over 2, which is 6 kilometers per hour. Alright, so that's how we calculate our speed. Alright, so whichever approach you choose to use, whether you choose to use your gradient approach, you choose to use it as just speed is distance over time, you're still going to get the same answer. Okay, next part of the graph that we should be interested in. This little portion from 2 hours to 4 hours. Well, not 4 hours, it's actually here. Alright, so anybody wants to tell me what is happening here between 2 hours and this particular point? We'll talk about that in a bit. So let's see what Nadia is. The person stopped. So we have the person stopped. Nadia is just saying, I've never understood. Oh, the minus one after the quantity. The h to the minus 1, or s to the minus 1, or any quantity units to the minus 1. This simply means that you were dividing. So in physics, there is this thing called dimensional analysis, which actually helps us deduce the fundamental units for any quantity, and that is what you'd understand, that when you do division, this is where this to the minus 1 comes from. And to be fair, like you could go back to indices as well and you would understand where this minus 1 comes from, but the quantity, as you were saying, the quantity to the minus 1, unit to the minus 1 simply means that you were dividing by that particular quantity. So if you see h to the minus 1, which is the unit for time, it's telling you here that you divided by time, so that's why the result is going to have kilometers, and then h to the minus 1 comes from the fact that you divided by time, which was measured in hours. You would be also pretty familiar with seeing the units for speed being written like this: kilometer per hour or meter per second. So this way, the slash then sort of denotes that division. It's being measured, the distance is being measured per hour. Alright, so that's where the minus 1 comes out from. That's why also for acceleration you'd have s to the minus 2, because you're dividing by a unit that is raised to the power of minus 2. Yes? Yes. So the this, as you were saying just now, the inverse, right? If you'll remember inverse reciprocal as well, this 1 over x is the same as writing x to the minus 1. That's what I was saying. It ties back to indices. If you remember indices, it ties back to that. That's where this h to the minus 1 comes from. So that was like a little tangent, but hopefully, as Nadia said, thank you, I hope that cleared up where the minus 1 came from. So if ever you see stuff like that, you wouldn't feel too confused. Again, you'll know how to get it. So that's where your minus 1 stuff comes from. Okay, back to this. So yeah, like I was saying, always of interest to us in a travel graph when we see this flat line, and somebody just mentioned that the athlete would have come to a rest at this particular period of time. So a question that could come out of this, and I believe that was the question they asked: how long did the athlete rest for? So can you all tell me how long the athlete rested for? So we're looking at it. Thoughts? Lovely, an hour and a half, because he started resting at 2 hours. He or she started resting at 2 hours, and that rest lasted for 1 hour, and then between 3 and 4 would be a half an hour, so 3.5 hours. So this means that the athlete would have rested for an hour and a half in total. Alright, lovely. So that's what happened here. He took a rest. So probably run the distance, was a little out of breath, was like, I need to catch myself before I go back home. So take a little rest. Okay, final leg of the journey. So after he rests, he decides, okay, time to get back home. What do you all notice about the return trip? Right? So yes, we know this is a return trip because it is sloping downwards, meaning that we've changed our direction here. But what can you all look at this little section and tell me about it? What do you all notice about it? As compared to, let's say, yes, that's self. It's shorter. He took a shorter time to reach back home than to get there. I don't know if anybody ever experienced this before, but you ever went somewhere with like your family, but it was like a strange place to you, and you find like to reach there felt like it took forever, but then to reach back home it was like so fast. Anybody ever experienced? Alright, okay, so that's what I was the only person. So that's something that I've always noticed. Like sometimes you would go somewhere and it's like, it's the first time you're going to this place, but you're feeling like it's taking forever to get there. And then when it's time to go home, it's like, oh wow, so fast. Did we reach home already? So yeah, that's probably what happened with him. The goal was, I need to get home, and that was just so clear in his mind that it was like, you run down the road real fast. So if I ask you all to calculate the speed on his return journey, I want you all to be careful with this one because it's going to be a little bit tricky. But tell me, do your calculation, and what do you think is the speed the athlete has on the return trip? So take like 2 minutes and calculate it. Tell me what you get. So as soon as you get an answer, you can just drop it on your chat. It'll be a nice place for us to compare answers and see what people get in. Right. So remember, again, speed is still going to be distance over time, but I'm sure some people probably calculating that speed right now and watching it like, what? How I get this answer? I do something wrong, and you're probably scratching your head a little bit and saying to yourself, you do something wrong somewhere, and then you're trying to manipulate it to see if you could get the answer that you think it should be. But tell me, if you've gotten an answer already, drop your answer. Right or wrong, drop your answer. Let's see what you got. Nice. So I have 2 answers. Let's go see what they got. So nice. So Alyssa got 8, Rihanna got 8, Nadia got a minus .13. Alright, so I like that I'm seeing that Nadia has a minus sign, and I'm liking the answers I see with Alyssa as well as Rihanna. Renita, you have a question? Okay, so your hand was up, so you can take it down. Alright, nice. Mayasha says she got -8. Lovely. So I'm seeing 8 as a popular response right now. We have 1 -8 and we have 2 positive 8s. So let's start off. How many people got the same thing Mayasha got? Raise your hand. I just do something. I don't know. Don't be so quick to discredit yourself and your work just yet, Mayasha. Raise your hand if you get the same thing Mayasha got. Oh yeah, -8. Alright, so there you go. See, Mayasha, you have company. So right now we have a 50-50. We have +8, we have -8. How many people got -8? Raise your hand if you got -8. So I know 2 people already who got -8. They already put their answers. Tough crowd today. Okay, let's see if the positives have it. So are we on the positive side? Did you get +8 kilometers per hour, whether you wrote km/h, km/h -1? Do you have +8 kilometers as your answer for this speed on the return journey? Raise your hand. Boy, today is a tough one. Alright, so even Calissa got the same thing. She got 8 kilometers. So we have 3 people for the positives. So, okay. Raise your hand if you get nothing at all. Raise your hand if you got nothing. Zahira got nothing. Oh my goodness. No response whatsoever. Raise your hand. Let's see how many people just sat there and looked at it, probably tried, got something, and was like, this completely wrong, and just decide to say they have nothing. So raise your hand if you have nothing for your response. -8. Alright. Let's see. So Jada and Zahira both got nothing. Leilana got nothing. Oh my goodness. Ashley got nothing. Wow, a tough crowd today. Because there are about 30 something people in here today, and I hardly have responses. Well, Renita is telling me that she got something completely different. At least she got a response, I should say. So, are you all ready for the answer? If you're ready for the answer, raise your hand. Let's see. How many people are ready for the answer? Alright. So we do have a few hands popping up. We want to see the answer. Alright. So for my persons who probably have a response and are quietly contemplating whether or not they are right or wrong, the correct answer is the 8 kilometers per hour. And we're going to talk about why the correct answer is positive 8 kilometers. We're going to talk about that negative that we did see pop up inside there in the discussion, and we're going to talk about the people who got absolutely nothing whatsoever. Alright, so let's start off with the calculation, because it's maths and the answer obviously comes from some kind of calculation, right? So here we go. If I want to calculate the speed on the return journey, I can do, like I was saying earlier, one of two things. I can take the fact that I'm going to be covering a specific distance over a particular period of time, and I'll get an answer. So this is something that probably would have happened to some people. We start off by saying speed is distance over time. Yeah man, we know what we're doing. And we know that the return journey is going to cover a total of 12 kilometers, because he did cover 12 kilometers when he came to arrest. So if I'm covering 12 kilometers from where I currently am at to go all the way back home, that's the distance I covered. How long did I take to cover that distance of 12 kilometers? Well, I go to my x-axis and I look at the time. When did I start this routine trip? My rest ended at 3.5 hours. So that means at that point in time, my return journey begins. And I will take a total of 30 minutes plus an hour. So that's 1.5 hours on my return journey. Alright? So just in case people didn't know what time to use, that is how you're going to get the time that you're going to use. The time to cover your return journey comes from how long it took to cover the 12 kilometers to go back home. So a total of 1.5 hours. Now, if you were one of the persons who probably did this and you just sat there and was like, how am I supposed to do this? Then at least you already got a start to what you're supposed to be working out. Okay, you could write this as 12 divided by 1.5 if you want, or for those of us who aren't totally intimidated by fractions, 1.5 as an improper fraction is going to make your life a lot easier to do this computation. Okay, so 1.5 will give me 3 on 2. I'm dividing by 3 on 2, but if I am doing division of fractions, we go back to primary school for this one, and we will change the sign to a multiplication sign and flip the fraction which follows, which will leave me with 2/3. And from here, that's where I'm going to work this out, and I'm going to get 8 kilometers per hour. Alright, so that is how you compute the speed for the return journey. I was just looking at before. Oh, that is what happened to Renita, eh? So Renita said, oh, you put 45 minutes instead, and you didn't look at it. Okay, So when you are working out your return journey, obviously the time is going to be very specific to pay attention to the time that it takes to cover the distance. All right, don't only look at the time as in the amount. So for example, to say you take like 5 hours or whatever, you didn't take 5 hours to do your return journey. You're counting your return journey time from here onward. All right, so you could use a decimal if you prefer, or you could use the fraction. Now, I want to talk about the negative part of things. A lot of things can happen depending on how you decide to find the speed. So if you decided to do it this way, where you were just looking at the quantities themselves and you knew you covered 12 kilometers over an hour and a half, you'd be able to just work it out like this. But let's say you decided to go the approach like this one, where you find the gradient. And let's say you took the coordinates of this point, which would have been 3.5 and 12, and this one, which would have been 5.0. And then we started the y2 minus y1 on x2 minus x1, and we started to substitute our values. And in substituting it, we started to notice something like this. So if we decided that we were going to use this as the x2, y2, because the values are larger, you could use any one. But you decided to go that way. So you did 12 minus 0. And then you had the 3.5 minus 5. So now you end up getting something like this. So you have 12 over a negative 1.5. And you start freaking out because you're like, oh my goodness, how could I ever get a negative speed? So all you need to know about when you get values like this, like let's just say you're using that approach, you ignore the negative, because we understand, right, when it comes to a distance time graph, the negative slope is indicating to us that we are changing direction, we're moving in the opposite direction. So that is why we're going to be getting this negative, all right, a negative gradient here. So if ever you're doing a computation, like you all would have noticed people had gotten -8 in the chat. That's the reason why they would have gotten -8, because it took this approach. It's not to say that they're wrong, it's just that you need to know how to interpret the value that you get. So because you understand you've changed direction, you're just taking the speed that you get, which would be the 8 kilometers per hour. Alright? So for the people who got in negatives, you're all A-okay now? Alright, lovely. Once you're all good to go. Alright, so another thing that could come out of a distance time graph or a travel graph in general, let's say they ask you all to calculate the average speed for the entire journey. The average speed for the entire journey. What do you think you will do to get the average speed for the entire journey? Anybody? Think about it, average speed for the entire journey. So in the meantime, I'm going to erase all this as I patiently wait. A very, very brave volunteer telling me, yeah, I'm listening. Ooh, lovely. So I'm hearing a nice little suggestion, so that's a good start. At the time to and from. Okay, so yeah, essentially what you want to start off by doing is this. In the initial stage of the journey, we had a 6 kilometers per hour speed. We had a return journey of 8 kilometers per hour. Now, although during this particular period there was no movement, you still have to take into consideration it's part of the journey. So if ever you have to get the average speed for the entire journey, right? Average speed for the entire journey will be something like this. You add all of the speeds throughout the entire journey and divide it by the total number of speeds you would have added. So that's how we'll just get our average, okay? So in this case, we're going to add, so average speed is 6 plus 0 plus 8 over 3. So you'll get 14 over 3, which is 4 point, recurrent decimal, 4.67 kilometers per hour. Alright? So if ever they ask you for average speed for the entire journey, you have to still consider the fact that you took a total of 5 hours anyway to travel the full distance, and that's where you have to add all the speeds during each respective part of your total journey. So you add all 3 speeds together. Alright? And even if you decided to do something like this, the total distance covered would have been 12 kilometers to go to whatever is this location, and then 12 kilometers to come back. Right? So that's a total of 24 kilometers being covered, and then you took a total of 5 hours to do the entire journey. So you wouldn't really get the same exact 4.67, you'd end up getting 4.8 kilometers per hour. But if ever they ask you for average speed, this is what you're doing. Alright, this little piece inside here. Find the sum of the 3 speeds that you would have calculated and divide it by 3. Alright, so that is what a question involving a distance time graph could